This video is about applying properties of angle pairs formed by parallel lines and a transversal. So there's a couple of theorems that deal with our angle pairs we talked about yesterday. So if parallel lines are cut by a transversal, then corresponding angles are congruent, which means they have the same measure. If parallel lines are cut by a transversal, then alternate interior angles are congruent. If lines are cut by a transversal, then alternate exterior angles are also congruent. So there are three relationships that make the angles congruent. Those are corresponding alternate interior and alternate exterior. Now, if parallel lines are cut by a transversal, then same side interior angles are supplementary. And same side exterior angles are also supplementary. Remember that supplementary means they are two angles that when added together equal 180 degrees. So we are going to look at some angle pairs and we are just going to identify what type of angle they are and then what their relationship is. So are they congruent or are they supplementary? So in number one, we have two angles that are in the same position in their groups of four. So these are going to be corresponding angles, and corresponding angles are congruent. In number two, we have two angles. They're on the insides of the lines, and they're on the same side of the transversal, which means that they are same side interior angles, and their relationship is supplementary. In number three, we have angles that are outside the line, so they're exterior. They're on opposite sides of the transversal, which means that these are alternate exterior angles, and alternate exterior angles are congruent. In number four, we have angles that are between the two lines, so that means interior, and they're on opposite sides of the transversal. So these are alternate interior angles, and they are congruent. In number five, we have angles that are on the same side of the transversal, and they're on the outside of their lines. So these are going to be same side exterior angles, and their relationship then is going to be supplementary. So now we're going to use those relationships to solve for a number. So in number six, we have that A and C are, or B and C are parallel. These two angles then are on the same side of the transversal and they are between the lines. So they are going to be same side interior angles, which means that they are supplementary. So we have 125 plus x plus 15 is equal to 180. So we get x plus 140 is equal to 180. We can subtract 140 from both sides, so x is 40. In number two, to solve for x, these angles are in the same position in their groups of four. They're both on the bottom right-hand side of the transversal and their parallel lines, which means that they are congruent because they are corresponding angles. So they are corresponding and they are congruent. So we have 4x plus 10 is equal to 110. So we can subtract 10 from both sides. 4x equals 100. When we divide, x is 25. In number 8 and 9, we want to solve for x and then find the measure of angle 1. So in this case, these angles are same side interior angles. Sorry, they're alternate interior. And alternate interior means that they are congruent. So 5x minus 43 is equal to 3x plus 17. So we get 2x is equal to 60. So when we divide, x is 30. Then to find angle 1, Angle 1 is a vertical angle to the 5x minus 43, which means they are going to have the same measure. So 5 times 30 minus 43 gets us 107 degrees. So angle 1 is also 107 degrees. In number 9, these angles are same side exterior angles, which means that they are supplementary. So we have 10x plus 66 is equal to 7x plus 12, or sorry, plus 7x plus 12 is equal to 180 because they were on the same side of the transversal and they're on the outside of those parallel lines. So as we solve, we get 17x plus 78 is equal to 180. We can subtract 78 from both sides, so 17x is equal to 102. We divide x as 6. Now, this time, angle 1 and 10x plus 60 form a straight line. So we're going to do 10 times 6 plus 66 is 126 degrees. So if they form a straight line, we can subtract that angle from 180. So 180 minus 126, and we get 54 degrees. In number 10, A is parallel to B, so we're going to add the arrows so that the lines are parallel. So these other two lines that I'm going to highlight in yellow and in blue are transversals. So if I want to solve for x, these two angles have a relationship and these two angles have a relationship. So the angles on the left with the yellow transversal, those are going to be same side interior angles, which means they're going to be supplementary. So we have 12x plus 32 plus 6y plus 40 equals 180. So we can get 12x plus 6y plus 72 equals 180. We know that if there's an x and y, this is going to be a system at some point. So we can subtract 72 from both sides. 12x plus 6y equals 108. Then let's look at our other angles. So the other angles here are on the inside of the line, but they're on opposite sides. So these are going to be alternate interior angles, which are congruent. So we have 6x plus 5y equals 62. So now we have a system that we can solve. So our two equations are 12x plus 6y equals 108 and 6x plus 5y equals 62. So to eliminate our x's, we can multiply by -2. So we get 12x plus 6y equals 108. And we get negative 12x minus 10y equals negative 124. So we can add our equations straight down. The x's cancel out, so we have negative 4y is equal to negative 16. We can divide by negative 4 on both sides, so y equals 4. So we have 12x plus 6 times 4 is equal to 108. 12x plus 24 equals 108. So we can subtract 24 from both sides. 12x is equal to 84. So when we divide by 12, x is equal to 7. So our solution here then is going to be 7, 4.